focusing. How can I get it to focus? Oh, I'm sure it'll fix itself. Regardless. Perhaps I'm going to cover the camera. Okay, maybe that does nothing for me. There are a few things that I gotta get done today. They're all listed here. Leetcode, read about system design, learn about indexing techniques in database systems. There's this group registration that I gotta do. Doesn't take too long, and then some of the stuff that I've been putting behind, I need to do as well. Which means, you know, most of this stuff is just study, and then hopefully by the end of the day I can get onto some assignments. We'll see how much I can actually do at the end of the day. Hopefully we can reach possibly around here, and then maybe this can be done tomorrow, this can be done tomorrow, possibly. You know, I'm probably going to move some of this as well. Group diagrams, that's pretty much done. 3D modeling methods. Alright, 3D modeling methods, we might just to save the stress having to think about it, put it off to tomorrow. And the second one, you know, that ideally assignment 2 in CS. I'll just rename these. Okay. That's the other thing, this presentation slides, we need to put priority. I do gotta remember that. In which case it might go here. The chances of me getting onto this then would be slim to none. So if I do push this back, it'll mean I'll push these back, mean I'll push these back, and I'll push these back. We need to do these presentation slides ASAP today, so that would ideally be first priority. I think it would be fine if I put it here. I'll still have enough time during the day to get that all done up to speed. These, on the other hand, are going to be a little harder to get all done. would say this is still something that I'll probably have to end up doing tomorrow. Alright. I say investigate 3D modeling, but I don't know how often how likely I'll get that done. But, you know, this is the structure of the day. Hopefully we can get through these top 3 within the next hour or 2. Next hour or 2. Okay. Camera's still not focusing. I don't think I can make it any better, to be honest. Perhaps I just gotta attempt something. Desk view. Hello, hello. Okay, I think that worked. Let's do one monkey type. 100% accuracy, 51. Okay, that's pretty clean now. I'm pretty clean with that. That's basically the best score that I've had in a while, probably in forever. I'm guessing that's pretty loud. You guys can hear, it's like outside. Hopefully it shouldn't be a problem. It'll be gone in a sec anyway. Max area of island. You are given a max grid where grid I is either 0 representing water or 1 representing land. An island is defined as a group of ones connected horizontally or vertically. You may assume all 4 edges of the grid are surrounded by water. The area of an island is defined as the number of cells within the island. Return the maximum area of an island in the grid. No island exists, return 0. So, in the previous question to this graph problem, it was to find the number of islands. Now in this problem, you can probably extend from that problem find, the maximum here, but how would you go about it? Say you look in the first top left cell and you say, okay, that's a piece of water, you don't need to worry about it, move to the next. You go to the first row, second column, and you realize That is a piece of land. Okay, let me do a breadth first search on this and see what is the maximum number that I can get from doing this breadth first search. And if I find that maximum number, once I find that maximum number, I store that into a max variable. If that is the maximum in the max variable. Alright, so we're probably going to have some max result equals 0 originally. And you know, we're probably going to say max of res and some value. Perhaps, you know, we call this area. And yeah, we just have to return the result max. Yeah, result is the max area. All right, just saying. Okay. Sure. So rows is equal to the grid, and I guess we can write this in one. Rows and columns is equal to grid and grid of 1, 0. I mean, we can only say that when we have grid existing. If grid, so if not grid, and or not grid 0, right? Because we know it's going to be 2D. Then you would return 0, or you would just return. Yeah, okay, we'll just say return 0. Do I really want to do it this way? Yeah, I think I'll do it this way. Undo. Okay. Okay. So these are the rows and columns. If rows, not if, come on. For row in rows, for C column in columns, if the grid row column is equal to, so these are all I'm guessing these are all strings. Oh no, lists of integers. Was the previous one list of strings? Wait, no. Count of number, yeah, list of strings, and now this is a list of ints. So we're kind of okay to just go like this. So if it's 1, then BFS so this is how they did it last time. I'm just trying to see how that could make sense. So you have 1 here, and you do the breadth first search, and after adding all the 1s to this, it means you might need a set, right, to say which ones you've visited. might need to add this up here. So visited set the breadth first search of the row and column. So you start at row and column, and that should return you an area, right? And then you would say, you know, you would do this. So and you know, if it's already visited, then you don't need to check it, right? So if row and column in visited, you don't need to check that one anymore. And so at most you would do this breadth first search 3 times, or yeah, 3 times for this example, because there's only 3 islands. And then you would just return the result. And then this problem becomes then how you would go about the breadth first search. So perhaps the definition of breadth first search is some Q, which is equal to collections DQ we'll initialize it with the list of row column and while Q is not empty, you want to add, you know, append the specific row and column that you get from row and column in the Q dot pop. So this is pop and not pop left, except it should be pop left because you're doing a queue. If we were instead doing a depth first search, a stack, I mean, it doesn't matter. It doesn't matter here. In this case, I don't think. So the other part of this is you need to have the directions to visit. So if grid of dr dc is equal to, man, that's incorrect. DRDC, I can't call it DRDC. I think that's what I call it for something else. NR, maybe. NC, okay. New column, new row, new column is equal to 1. If that's equal to 1, then you append the new row and new column. And if, let's see, I could specify the directions here is equal to 0, 1. So that's going to be, you know, maybe the row and the column, so it's going to be down. This is going to be 0, -1 is going to be up. You're going to have 0, 1, and 0, which is to the right, and -1. Oops, -1 and 0 to the left. Okay, so those are your directions. For direction in directions, this is where the dr and dc comes in. So dr, dc, nr is equal to row plus dr, and c is equal to column plus dc. And these just get shifted across, and we can put this probably as a constant. Okay. I don't see why this wouldn't work, except yes, we haven't even at all added it to a visited list. So visited is would only happen. Okay, I take that back. It should only happen here. R and C. It might not work because I feel like I would have inevitably missed something. Okay, so if grid RC, this is in here. Gotta see what that says here. So print grid R. Okay, so this is probably not gonna work again because no output. So list indices must be integers or slices, not list. So for R in rows or C in cols. I suppose what I forgot here was the range, because otherwise the rows would be the actual rows. Perhaps. This makes me think, right, we need length. Okay, that would be it. I believe I'm just getting. Okay, so that's printed something. Your output is 0, expected output to be 6. That's alright, so keep on going. Then the question is, okay, right, you don't return anything here when you should. So you should return the area that you find, which you only find by initializing area to 0. And every one that you see, area plus that's just going to be one of the islands. Okay. In this process, let's just also print the area, just to see what that looks like. it's not even being run, it looks like. Okay, so let's just double check the value of, say, print. The conditioning here, so grid and we'll print visited as well. Okay, the set is empty all the time. Now that's a problem. We have to see what visited here is. So this is, say, inside BFS, and we return visited. Okay, just see what that shows us. Again, it's just not even being run. Okay, right. And not in. Then you do the BFS, then you do the answer. Okay, and list index out of range for sure. Because, say, yeah, we make no checks on whether it's within bounds or not. So to do that, so we'd have to check that NR in range of R and so we'll say NR not in range of R and NC not in range of C. Then you continue. And let's try that again. Okay. Spit out limit exceeded. Okay, control, so undo, delete that. Actually, maybe I'll keep that. And instead delete this. Just see. So the output ends up to be 0, 0, 0 all the time. Okay, I chose the wrong row and column, so cols, rows, okay, sure, time limit exceeded. This node that. It's definitely doing an infinite loop. Perhaps I need to also add it here. New row, new column. I think that is what I'm missing. Not in visited. The new row, new column, not in visited. You add the area, you add the number. Okay, so still we found that error. That's good. Got 5, got 3. I mean, it might not be using the same. Is it using the same? Yes, it is. It's using the exact same. Okay. Oh, I can just run the test case. I gotta do this more often. Oh wait. It is. My apple was 5 and the apple was 6. So 5 plus 3. So okay, let me get rid of some of this noise. Oops, that's not it. Control, undo. Let's get rid of this. So 5, 3, 1, 2, 3, 4, 5, and 1, 2, 3, 4, and 0. Okay, so possibly I'm just missing a 1 to start off with. Alright, so perhaps. Expected output was 4 for the 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 apples. Let me think why. So you find 5 and 5 when you started off with 1. So it doesn't work for all of them. It's not that easy. Let me think about it. So 0. Why would it have perhaps it's this, where you should check when you're on the node before continuing. So if you check yourself on the node, oh man, this is gonna be, okay, this is a bit of a pain. So if grid row column is equal to 1 and row column not in visited, if none of the next ones are 1, you'll never reach, you'll always have one less. That's a problem. But if you check it here, you're doing the check, and then you add it to the visited. Okay. So end RC not visited is guaranteed to be the case if it comes from this. So you add the area. Okay. So maybe perhaps you just also add the zeros. It's 124. Something's wrong. I messed up somewhere. Okay. I'm trying to look at the solutions here. Matrix DFS, matrix DFS. Rose calls, yes. Visited sets. Very sure. Yeah, something like that, a bit more. The area. Get the max area of the DFS card. See, that's kind of what I did. Except I did this extra condition. Perhaps maybe it's not necessary. I'd say I have the right idea, but also, yeah, no. I can understand the DFS solution though. You add up all the possible other DFSs. You return 0 if any of these conditions exist. So R is less than 0, or is R is equal to rows, C is less than 0, or C is equal to columns, or the grid RC in 0, 0. If that's 0, then you return 0. And RC invisited, you would return 0, otherwise you'd return 1 plus. So look, the DFS solution is easier. It is, but I also want to use a Q for the DFS, so yeah. And I still just need to figure this out, you know? Still just need to, it's down to the conditionings, the conditions that I have right now. So I'll just continue it this way. Just say for another 5 minutes, right? If I can't figure it out in 5 minutes, then I'll just potentially consider rewriting or just copying the solution. But okay, run through, try and debug. We're certain all of this is fine, so we don't need to worry. The BFS should return an area, which then you result is equal to the max of the result or the area. That's also fine. This condition, when the grid is equal to 1, you do the BFS, and RC is not visited, it'll just mean that at most you do 3 BFSs. Okay? That's no different. That means the inside here is what we're worried about. The BFS here is what we're worried about. The area initializes to 0. Later on, we'll return that value. We have a queue, which first initializes to the row and column that we were given. And from the row and column, this is indexes, so row index, column index. This will be popped from the left, so it's a stack, and you check that this is equal to 1. If it is, then the area is 1 now, and that row and column becomes visited. From then on, you also need to check every other direction from that row and column, and in that case you would define the new row indexes and column indexes, and if it's not in the range of the rows, or NC is not in the range of the columns, then you wouldn't do anything with this, you would just continue. Otherwise, you would check that if the new rows and new column is not invisited, you would add an area of 1. Okay, well that's not what you need. You would add this value into the queue. Right, so this whole step just adds something into the queue. Still returns a very large number. Perhaps you still need, so not invisited, so it must also be that the grid of the new row and the new column is equal to 1. If that's the case, you wouldn't need that. Five and 5 output 5 when you meant to output 4. Oh, we got the same issue. So what's the difference between these, right? You go from here, you reach this, you find 1, 2, 3, 4, 5, 6. Alright. You go next, can't do, next, can't do, next, yes you can, so you find 4. Next, yes you can, you find 1. No. Okay, so that's the extent of it. Alright, so you got 6 as your output. Cool. Now, we fail on this example. So we're going to use this test case and just run it on this test case. So we have 1, 1. We have 1. You know you can find 4, not 5. So why does it return 5? And you know the second one is going to be 4, and yet you return 5. So let's check exactly when we do this add. So we print the row and column. Okay, and when we print print it, we go, okay, 0, 0, yes, 0, 1, yes, this. But there's an 1 and a 1 again. Perhaps it's because it's an overlap, right? And you're adding that. If that's the case, just to ensure value doesn't get added twice. Okay. Taking a guess. Please. Nice. We did it. We did it finally. Not mad. Not mad. Alright, so we're kind of good, but this is kind of also massive. Only found out from running all those tests. We figured it out it went over time by a minute, but okay, we did it. What's this specific one called? Max area of island. No. Why do we have that? I think we're gonna have that same issue again. Control All, Control C, maybe I'll do it this way. Paste. Yeah. And we'll paste it here. And we'll make a note of this in Obsidian again. that was binary right side view. We can create a new one for max area of island, where we have this. Of this, we add BFS, or you can do DFS, or you can do it's a graph, and use a DQ. My only note to say is, first graph problem I solved myself, but it was very similar to graph. Number of islands. Max area, I don't even have one. No, I definitely do. I definitely do. What do I call this? It was like boilerplate code. Perhaps I never wrote it in its own thing. Yikes, man. Doesn't matter, I'll skip that. It just means that I kind of need to copy this. Paste here. What's with the indentation? Okay, this graph problem had lots of bugs when I first created it. I solved it well after stepping through each line one by one. Okay. Now, we can go to the next thing, done Leetcode. We can read this. So I was up to low-level design. Up to here, URL encoding techniques. Let's see. Barker Camp No phone unlocked codes. I don't know what that is with respect to here. Okay, URL encoding techniques to create shortened URLs. Yeah, we can use some hashing technique like base62 and MD5. We can discuss both of these approaches. Base62, The tiny URL should be unique. First check the existence of this tiny URL. If already present, there is some other long URL, and get a new short URL. If short URL isn't present in the DB, put the long URL and tiny URL in database. Yeah, I mean, that all makes sense. Is that something that I can regurgitate, you know? Like, is that something that I can come up with on the spot as well? I think I can. Like, it would make logical sense what you would do in those scenarios. The only concern is how foolproof. Not the word. It's how well it meets the interviewer's standards. So I guess with that case, I should just ask a lot of clarifying questions on what they'd exactly like to see in the system design still. You know, like, would you like a database schema? Would you like, you know, the API calls? I mean, those are probably almost standard to include. Maybe during the call of the creation of the URL, when you create a URL, you have to first check that the URL exists inside the database or not, and if it does exist, then you would directly return the newly created short URL, or well, the recently or past created short URL. Perhaps, you know, that's to, yeah, say you don't, right? Say you don't give the same URL, tiny URL, for every new URL. If you don't, then perhaps when you check this long URL exists in the database or not, you make it a linked list of tiny URLs for that specific long URL. This long URL might be hashed in some way. Again, you know, base64, MD5, you hash it in some way so that you can query that URL efficiently. I mean, yeah, and then you'd store it in a linked list potentially of tiny URLs. Like, that's how I'd see it playing out. Okay, this technique works with one server very well, but there will be multiple servers, then this technique will create a race condition. when multiple servers will work together, there will be a possibility that they can all generate the same unique ID on the same tiny URL for different long URL. Even after checking the databases, they will be allowed to insert the same tiny URL simultaneously in the database, and this may end up corrupting the data. Yeah, for sure. So we can use put if absent or insert if not exist condition. While inserting the tiny URL, this requires support from DB, which is available in relational database management systems, but not in NoSQL. Okay, sure. So using MD5 approach, you encode the long URL using the MD5 approach and take only the first 7 characters to generate tiny URL. Okay. The first 7 characters could be the same for different long URLs. So check the DB as we have discussed in Technique 1 and verify that the tiny URL is not used already. This approach saves some space in the database, but how? Well, if 2 users want to generate a tiny URL for the same long URL, then the first technique will generate 2 random numbers, and it will require 2 rows in the database. In the second, both the long URL will have the same MD5, so we'll have the same first 43 bits. This means we will get some deduping and we will end up with saving some space, since we only need to store 1 row instead of 2 rows in the database. We can use put if absent, but NoSQL doesn't support this feature. So let's move on to the third technique, using a counter approach. Sure. So using a counter approach is something that is interesting, because I don't know what that is. Using a counter approach is a good decision for a scalable solution, because counters always get incremented, so we can get a new value for each new request. Okay, how does that work in a distributed system though? Anyway, so single server approach. A single hosted or server, say database, will be responsible for maintaining the counter. When the worker host receives a request, it talks to the counter host, which returns a unique number and increments the counter. When the next request comes, the counter host again returns the unique number. And this goes on. Every worker host gets a unique number which is used to generate the tiny URL. Now let's discuss a problem. If the counter host goes down for some time, then it will create a problem also if the number of requests will be high, then the counter host might not be able to handle the load. Yeah, that's what I was thinking from the get-go. So challenges are a single point of failure and a single point of bottleneck. So what if there are multiple servers? You can't maintain a single counter and return the output to all the servers. To solve this problem, we can use multiple internal counters for multiple servers which use different counter ranges. For example, server 1 ranges from 1 to 1 million, server 2 ranges from 1 million to 10 million. And so on, but still there are some problems with this architecture, such as if one of the counters goes down, then for another server it will be difficult to get the range of the failure counter and maintain it again. If if one counter reaches its maximum limit, then resetting the counter will be difficult because there is no single host available for coordination among all these multiple servers. Again, that's what I was thinking. The architecture will be messed up. Alright, yeah, very descriptive term. So messed up since we don't know which server is the master or which one is a slave and which one is responsible for coordinating and synchronization. Now let's discuss the solution. To solve this problem, we can use a distributed service Zookeeper to manage all of these tedious tasks and to solve the various challenges of a distributed system like a race condition, deadlock, or particle failure of data. Interesting, so you can use a Zookeeper to fix all these problems. Zookeeper is basically a distributed coordination service that manages a large set of hosts. It keeps track of all things such as the names of the servers, active servers, dead servers, and configuration information of all the hosts. It provides coordination and maintains the synchronization between the multiple servers. Let's discuss how to maintain a counter of distributed hosts using Zookeeper. So firstly, Zookeeper here very much reminds me of Kubernetes. Yeah, that's all I gotta say. Okay, so from 3.5 trillion combinations, take first billion combinations. Okay, so Zookeeper maintains the range and divides the 1 billion into 1,000 ranges of 1 million. Each range is 1 to 1 million range, 1 million and 1 to 2 million and so forth. When servers will be added, these servers will ask for the unused range from Zookeeper. Suppose the worker 1 server is assigned a range 1. Worker 1 will generate the tiny URL incrementing the counter and using the encoding technique. Every time it will be a unique number, so there is no possibility of collision, and also there is no need to keep checking the database to ensure that the URL exists or not. We can directly insert the mapping of the long URL and short URL into the database. Is that an assumption that is agreeable? You know, I know it's going to be a different MD5 hash, but I guess it's under the assumption that you don't run out of MD5 hashes, and you know, the first 7 digits is enough. The first 7 digits of the MD5 hash is enough to uniquely identify each one of these tiny URLs. So we can directly insert the mapping of a long URL and a short URL in the DB without any checks. In the worst case, if one of the servers goes down, then we'll only lose 1 million combinations in Zookeeper, which will be unused and we can't reuse it as well. But since we have 3.5 trillion combinations, we should not worry about losing this combination. If one of the servers will reach its maximum range or limit, then again it can take a new fresh range from Zookeeper. The addition of a new server is also easy. Zookeeper will assign an unused counter range for this new server. We will take the second billion when the first billion is exhausted to continue the process. Okay, Zookeeper is a very concept, you know, like maybe, you know, this is the stuff again that I gotta be explaining to the person that is interviewing me. Will I remember zookeeper, specifically the term zookeeper, are probably hard to justify unless I do some research here. So zookeeper in database, distributed databases. I mean, I can also ask my friend, have you learnt about zookeepers? I better stand up. Hold on, Zookeeper is actually a product. Okay. Alright, Zookeeper. So hi Passan, I'm seeing your messages now. Long time no see, indeed. Is DSA needed for system design? I would say some part yes. In the system design that I did, actually, you had to talk about perhaps like what algorithm you would use inside this database itself. Although vaguely, I said something like a priority queue, and this was in the system design section. Anyway, okay. A high-level design of a URL shortening service. Cleanup services. Like cleanup services I wouldn't even be thinking about for a while. I think if you know DSA Basic, that is more than enough for learning system design. What about web dev? Are you done with it? I wouldn't say I'm ever done with web dev. You know, I'm still learning. I am currently though learning, DSA, yes, or just practicing Leetcode. On top of what I'm also learning. The music sound is too much? Okay. I am speaking a little soft, I would say. Hope this is somewhat better. Retro asks, how many Leetcode have you done till now? I'll show you. I'm showing you from Leetcode because that's what I've been using. That's how much I've done. Not much. 57. You see, I'm not even up to dynamic programming. Although I have an idea of how to do dynamic programming. System design for beginners. Okay, so I'll read through all this and then, okay, that's pretty much it, okay. User interface, clients, the user interacts. The user interface allows users to enter a long URL and receive a shortened link. This could be a simple web form or RESTful API, okay. Nice. Application server receives the long URL from the user interface and generates a unique short alias or key for the URL. It then stores the alias and the original URL in a database. The application server also tracks clicks, events on the shortened links. Yeah, sure. Load balancer. To handle a large number of requests, we'll use a load balancer to distribute incoming traffic across multiple instances of the application server. We can add a load balancing layer at 3 places in our service: between clients and application servers, clients and application servers, okay, and a second load balancer between application servers and database servers, okay, and an application server between application server and cache server. Oh, right, yeah. Okay. The database stores the alias or key and the original URL. The database should be scalable to handle a large number of URLs and clicks. We can use NoSQL databases such as MongoDB or Cassandra, which can handle large amounts of data and can scale horizontally. As soon as a key is used, it should be marked in the database to ensure it doesn't get used again. If If there are multiple servers reading keys concurrently, we might get a scenario where 2 or more servers try to read the same key from the database. Caching. Since reading from the database can be slow and resource intensive, we can add a caching layer to speed up the operations. We can use in-memory caches like Redis or memcached to store the most frequently accessed URLs. You have a cleanup service, which the service helps in cleaning the old data. Redirection, where a user clicks on a shorted link, the application server looks up the original URL and redirects you. Oh, and the original URL using 301 status code, which is a permanent redirect. Okay, yeah. Analytics, the application server should track click events on the shortened links and provide analytics to the user. This includes the number of clicks, referrer, the browser, the device used to access the link. Security, the service should be designed to prevent malicious users from generating short links or phishing or malware sites. It should also protect against DDoS attacks and brute force attacks. We can use firewalls, rate limiting, and authentication mechanisms to ensure the security of the service. Okay, so when it comes to the system design, I'm thinking it would be good to introduce, I guess first, after asking all the questions you need to ask, you start speaking about it from, say, okay, let's start from the client side. Maybe we start from an API which creates tasks, deletes tasks, CRUD operations on tasks. From there, you can, when you consider the creation of a task, you do this and this and this, and this is what the database schema would look like. This is how we'd create a task. This is if we do any checks, if we hash, and if we now consider what we do when we read. We would just generate the hash and check that the hash is indeed the key to the value in the database, perhaps. Yeah, okay. Cool. Security, the service should be designed to prevent malicious users from generating short links to phishing or malware sites. It should also protect against DDoS attacks and brute force attacks. We can use firewalls, rate limiting, and authentication mechanisms to ensure the security of the service. Sure. And database, let us explore some of the choices for system design of databases of short URLs. We can use a relational database management system which uses ACID properties, but you will still be facing the scalability issues with relational databases. So ACID properties is something I gotta remember again. Atomicity, consistency, isolation, and durability. Okay. Perhaps. eventual consistency. Okay. Okay. Cool. I'm happy. Okay, so now we can talk about different indexing techniques. Something I just got to consider. That's an index, attributes of indexing, clustering indexing, primary indexing, secondary indexing, dense and sparse. What is a foreign key? What is a primary key? A foreign key is another table's primary key. So if you have table 1 and table 2, the foreign key table 1 might link to table 2's primary key. I should have just explained it that way. I think it would have been quick and easy. I think that would have been the best way to explain things. Definitely, I did it on the spot and it was okay. It turned out okay. Happy with that. Always could do a little better. Okay, B trees are something that... Okay. I think I should investigate this. Yep, okay. General knowledge understood. Okay, so that's it. Cool, done in just about an hour, right? 2 hours. Okay, well, yeah, 2 hours. That's alright, that's good. Alright, I need to message my buddy. I'm gonna pause the camera feed for a second. It just gets worse and worse. Okay. Last one. Alright. Man, sad. Nah, I'm just thinking about something else. Okay. Okay, there is something that I should maybe try. Order configuration. Okay, so guys, I'll be back. The stream, the broadcast. Stop broadcasting. Be right back.